Hey everyone, thanks again for joining us here for Mastering Observability of your serverless applications. Again, my name is Chris Munz, currently Senior Manager, Principal Developer Advocate for Serverless at Amazon Web Services. Now, I've been at AWS now for a total of just about 8 years across a number of different roles, but today I manage and lead the team of developer advocates focused on the topic of serverless. And so my team produces and creates a lot of the content that you might see in these tech talks, on Twitch, on the Compute blog, a number of other places, talking about services that we're going to cover today, such as Lambda and API Gateway, and what it means to build and run applications based in those. What are we talking about specifically here today? Well, this term observability is another hot term in the industry, much like serverless is. And so we're going to dive into exactly what it means to add the appropriate observability tooling for your serverless application, and as well as kind of explore the products that are involved and some best practices. Now, when we talk about a serverless application, I want to be very specific. We're talking about applications that are based around AWS Lambda. So for those of you who are not aware, AWS Lambda is a compute service where you write your code into what we consider functions. These are typically small, single-purpose bits of code, and they could be in any one of the languages that you see here below, or you could use something called the Runtime API to actually bring any language almost to the platform. You then configure an event source. You can think of this as a trigger, something that when an action occurs, it is going to then execute your Lambda function on your behalf. And this is everything from calls to, for example, API gateways, to you could put an object into an Amazon S3 bucket and have it invoke Lambda. And there's a ton of different ways in which you can invoke Lambda through different event sources. And then what your code does is largely up to you. So it could be talking to databases or data stores, calling other APIs that exist out in your infrastructure on the internet. Again, Lambda is a general purpose compute service that you can use to do almost anything. Now, I want to get a little bit more specific here and think about a specific type of architecture. Now, this is kind of a really basic diagram for what we would consider a serverless web application. And so what we have here is a service called AWS Amplify Console, which you can use for hosting static assets such as HTML, CSS, JavaScript. So perhaps you're building a web application in, say, a modern JavaScript framework like React or Vue. You could use Amplify Console to host that application. You can then use a service like Amazon Cognito to handle authentication of your customers. You can actually do pretty much anything in terms of user management with Cognito, so store profile information, personal information, and so forth. And then lastly, and this is where we're going to spend most of our time focusing a little bit here, thinking about our API backend for this application. So our client that is loading through the data served out by Amplify Console can make calls to an API backend, which can be powered by Amazon API Gateway, which is a serverless API gateway service, which can then invoke our Lambda function, which can include all of our business logic. And then we could talk to Amazon DynamoDB, which is a non-relational NoSQL database meant for massive scale applications, but can do all sorts of cool things. And again, we could go into a lot of depth about each of these services. We're not going to do a whole lot of that today. Would encourage you to check out some of the other on-demand tech talks and content that we have out there as well. And so if you were to think about a traditional application stack that you might be looking to do observability for, in a non-serverless world, there's kind of some number, if not all, of the layers that you see here. And now cloud computing and infrastructure that you would run on AWS could help you reduce quite a lot of these. But really, it's only with true serverless infrastructure that you get down to really just caring about your business logic and your application and your business's data. And so in the case of the previous services that I showed a little earlier, you're not dealing with things like operating systems or virtual machines or containers or container orchestration, virtualization, server hardware, of course, none of that kind of stuff. And so you end up really getting to greatly reduce the scope of the work that you have to take on. So again, that's serverless. Now, what is observability? Now, again, this is another kind of buzzword in the industry. It can mean a lot of things to a lot of people, depending on who you talk to. And really, observability covers a number of different areas. Common things that people will talk about when you think about observability is that it's more than just monitoring failures. You're not just waiting for things to break. There's questions about, are things behaving as you'd expect them to? Is performance well within the range of what your customers need? in order to consume your application properly. What is that usage? So if you had a serverless application and nobody was using it, you would actually generate no data. Does that mean that it's down? Maybe not. But at the same time, is that usage within the bands of what you'd be expecting? And then lastly, what's the impact to the business? So if your site is really slow, it might still be available, but it might be so slow that your customers are leaving it. Or you could be having lots of errors being kicked up, even though it's functioning insofar as you're monitoring it. And now these are very kind of tactical questions that one might ask about observing the current state of an application and an architecture. And again, when people talk about observability in the larger sense, and there is a lot of stuff out there that you can read, you can find books, you can find all sorts of different articles and things that people have published. What it really comes down to is how your business and how your culture of your organization thinks about performance and failures and data collection and things like that, and then the practices that you put into that. It's more about how you monitor things in the maybe human sense versus the how in the tooling sense. That said, we're going to focus mostly here today on the tooling side of things. The cultural side, the practices side, that's something that, again, I think requires a bit more of a deep dive into your business and who you are and how you operate. And I'd encourage you to take a look at some of the other resources that you could find online for this. Now, when it comes to thinking about the tooling and observability, there are basically three pillars that you'll see people commonly talk about: metrics, logs, and then traces. And these are three very separate, independent things, as you can see here from the definitions shown below. And so today we're actually going to go through all three of these pillars and talk about the tooling that aligns with each of them. Now, for us here at AWS, that comes down primarily to two tools. Although I have to be honest that now both of these two tools are actually much larger than just two individual capabilities. So Amazon CloudWatch, one of the oldest services that we have here at AWS, provides capabilities for logging and metrics and alarms and events, and then the ability to build custom dashboards, and even more than that, which we'll go through here today. And then AWS X-Ray, which is a service which has been around for a couple of years now, supports concepts such as traces and analytics and a service map, which we'll go into as well. And so almost all of our conversation today is going to be focused on these two services and how you can use them with your serverless application. So let's dive in. So when we talk about CloudWatch, again, it's a fairly capable, sophisticated service, right? I really say collection of services inside of AWS. It's something that's core and foundational and built into most of our products. So actually, we'll see here today that there's a lot of things that you get just right out of the box with CloudWatch that you don't have to do yourself. And again, in terms of capabilities, CloudWatch is really meant for you to be able to collect data, potentially transport and then store it either inside of itself or off to another service. You can then query that data inside of CloudWatch. You can visualize that, you can alert upon that, and then you can take action from there. And so we'll talk through all these various kind of capabilities as we talk through again what it is that CloudWatch can do for you. And CloudWatch, again, is something that operates at a really massive scale. So today we do over 1 quadrillion metric observations each month. That's a really, really, really big number. And if you take this number and you divide it out by the minutes of this talk, you can imagine what I guess are probably billions of metrics that are being observed during that time. We also have a part of CloudWatch which is called CloudWatch Events. CloudWatch Events digests all sorts of events from AWS infrastructure. You can also do custom events. This is now also basically part of what we call EventBridge. But it processes over 3.9 trillion events. Again, trillion, a lot of events that are flying through that service. So it's already operating at an incredibly massive scale. Now, we trust these services that we built ourselves at AWS and with our peers over at Amazon.com. They are using CloudWatch and we're using CloudWatch every day to monitor infrastructure, to diagnose problems, to dive deep into things. And so this is something, again, that's well worn and battle tested at massive, massive scale. And then lastly, when it comes to logs, one of the stats that we have is 100 petabytes per month of log data that is ingested. And so again, you can feel confident in using CloudWatch to handle the monitoring, the log capture, the metrics capture, all the stuff that we're going to talk about here today. So now let's take the kind of three of the services in this stack. We're going to focus primarily on how Amazon API Gateway, Lambda, and DynamoDB relate and integrate in with CloudWatch and then X-Ray. And again, this kind of aligns with the three pillars of observability that we're talking about before. So metrics, logs, and then traces. Let's start with metrics. So right out of the box with CloudWatch and these three services, you get a lot of data. So what you're seeing here are built-in metrics that as soon as you configure an Amazon API Gateway and you configure a Lambda function, you get a whole bunch of this data. Now, some of this data actually will depend on the specific configuration of the resource. So for example, with AWS Lambda, provision concurrency and provision concurrency invocations and the other metrics that you see there are only going to be populated if you have configured provision concurrency for your Lambda functions. For those that are not aware, provision concurrency is a capability where you can essentially set Lambda functions to be very highly responsive by us pre-provisioning the resources ahead of time. So it greatly reduces cold starts. With Dynamo, whoa, a ton of data that you get, again, out of the box, depending on if you're using indexes, depending on things like replication that you can set up for DynamoDB. But again, there's just a whole lot of data that is generated for you, such that you don't have to think about generating extra data as part of this. And I think nowadays people come to just expect that from managed services. And so again, there's a whole lot of data that you can find here. But when it comes to your actual business application and the logic that you have, there could be more that you want to do. Now, again, all this data that is shown here can be visualized inside of the CloudWatch console. You can also pull this data out and pull it into third-party tools. So there's a lot of AWS's partners in the metric space, the monitoring space, and the observability space that will actually consume CloudWatch data on your behalf from your account and then visualize that, track that, alarm on that for you. But again, you can always hop right into the CloudWatch console and see those metrics. Now, as I was just saying, there's a lot of data that's made available to you, but this may not be everything that you need. So for example, there could be business level logic that you care about. There could be metric data that you want to graph related to user actions, related to consumed products or to types of products that you might have. There's all sorts of things that you might want to have custom about the data that you're viewing that you use for making decisions on the performance of your applications and how your users are consuming that. And so one option that you do have is creating custom metrics within CloudWatch. Again, this is a capability that's been in CloudWatch for a long time. And so what you can do is use the AWS SDK inside of your Lambda function. Now, this example that you see here on the other side of this is actually a Lambda function that just specifically spits out a data point. And this is related to a workshop that we have called Innovator Island. And so what it is capturing here is a type of data that has a dimension called ride, and then the ride has a ID assigned with it, and then it goes and sends out data in a unit called seconds. And so that's kind of in the middle of this code block here. And so with this put metric data command, you can kind of put data of any sort or type that you want that is a metric. Again, this is giving something in a time-based unit. There are other units that are available for you to use. And so with this, you can get, again, really fine-grained data that can execute every single time that your code executes or based on certain function capability. Now you're charged by the metrics that you create and then the put calls of data into a metric. So we see here that this metric has a specific name called wait times, and then it has dimensions of data that we're putting into it. So we'd be charged here for that single metric called wait times, and then every time that we put data into this. So every time that this function were to execute based on this. Now this is improved upon by something called embedded metrics format, which I'm going to talk about here just in a moment. But many of you might already be using the put metric data command, and there's nothing wrong with that if you are. So again, this is going to give you that ability to create those custom metrics, populate that data into CloudWatch. And a little later on here in the talk, I'm going to dive into the CloudWatch console and show you how you can pull out all sorts of information like this. Let's talk a little bit here about CloudWatch logging, which is kind of the next kind of key component in the observability triangle that we have. So with logging, again, we have built-in logging across API Gateway and Lambda that already provides you with a whole lot of information. And in fact, there's so much information that we give you the ability to control, what level it exists that we're recording for you. So built in, you have 2 levels of logging for API gateway, error, and info. You can optionally also turn on a full request body content logging. That can be a whole lot of information, but for troubleshooting reasons, you might want to turn that on. And you can configure this either at a per stage or a per method level. So you can really kind of get fine-grained in terms of what logging you want to configure. API Gateway also gives you the ability to set or create a custom log format that gets stored into CloudWatch. So maybe you have certain data that you do care about, certain data that you don't care about. It can go through and pull that out for you. With Lambda, there are some log lines that we capture automatically with every single request. So things like the duration of time, we'll also capture information in case there was an error. And then what you can do inside of your code is anything that looks like the equivalent of console.log for your language is output that gets captured by CloudWatch logs. So you can use this from everything from those kind of common debug statements that say, failed here, or anything more complicated than that. And then you can also use the CloudWatch SDK for put log events, which will allow you to enter in slightly more structured data if you so desire. So again, 2 different ways of doing this. One is just the console.log or equivalent. The other is actually using the CloudWatch SDK. With the first one, you don't need to include the SDK or import it or anything like that. With the second, you would want to do an import on the client SDK and then call the function with all of the various attributes for that call. Now inside of CloudWatch, there's a capability also called log pivots. And what log pivots allow you to do is to basically define a regex against your log data. And then what it does is as that log information is ingested, it will generate a metric based on that and push that into CloudWatch metrics on your behalf. So then you can jump between the two inside of the CloudWatch console. Again, the embedded format that we're going to talk about here takes it one step further, but this is something that's again built into CloudWatch today. And then lastly, if the CloudWatch console isn't giving you everything that you need to do deeper log diving, you want to visualize or look at it different ways. There are various different ways that you can explore this data, or I should say export this data out to things like AWS Elasticache or out to Amazon Athena or Amazon QuickSight via S3. And so lots of ways you can take this data out and then look at it in other places. And so if I wanted to create a custom message for log information, we see here that I actually have a JSON structure that I'm populating. You can pass this into, again, the equivalent of console.log. So you see a couple different examples for different programming languages here, where I'm actually taking that JSON, at least in the example of JavaScript, I'm going to do what's called stringifying it. So I'm just going to turn it into a solid kind of string. You see other examples of doing a JSON.dumps for Python and doing an os.standard out encoding in Go. And so each of these are just going to take that line, going to make it basically a single string, and then send that string out of Lambda. It'll get captured by CloudWatch logs, and that's all that you have to do for that. Now, again, this could be pretty powerful, but at the same time, we felt here at AWS that we could do better and improve upon this. So last year, we announced a capability called CloudWatch Embedded Metrics Format. And so with embedded metrics format, basically what it does is it combines a little bit of the capability of log pivots with the ability for you to consume custom log data. But it, again, adds a little bit of structure for it. So what you do with the embedded metrics format is you actually send log information that is highly structured. So it has a certain format to the JSON that you need to send with it. And you can do this either via a purpose-built client that we have, which today exists for Node.js and Python, or you can just put this back into the put log events call that we saw on the, the put log events call that is in the SDK. Either of those will work, but you do have to follow the specific format. So what does that look like? So again, previously we had this JSON structure on the left, which represents some information about my business and my customers and my application. And then what we see on the right is that format in the embedded metric format. So we see here that there is kind of an overall namespace to the JSON underscore AWS. We have a timestamp that we want to pass in. We then have the various CloudWatch metrics that we might want to capture from this. And so we see that I have a namespace called e-commerce cart. I have certain dimensions that I care about, and then the metrics that will be aligned with that. And again, this is just a brief example of what this would look like. Now again, what this is going to give me is both a log line and a metric inside of CloudWatch. And now I could take all of this, my metrics, my embedded metrics that generate log data, and I can build custom dashboards with this. So again, this is just with CloudWatch metrics and with CloudWatch logging. Then you can see here an example where in CloudWatch, with my custom dashboard, I've combined some log information and some of these other metrics that I have. Now that's again, just with the base capabilities of these two services, or the two capabilities to say inside of CloudWatch for logs and for metrics. But we can go a step further than this as well. And so one of the great things about the embedded log format is that it allows you to make use of a service called Amazon CloudWatch Logs Insights. Again, it's a newer capability inside of CloudWatch, which allows you to actually kind of dive a little bit deeper into that structured log, into the metrics that are created by it, and be able to pull out ideally useful information that your business might need. So let's say that based on a custom data that I've captured, that I want to look at the last 100 error messages that occurred inside of my application. Again, I'm spitting out the JSON that you see on the left via the embedded metric format into CloudWatch. And then I'm going to use the syntax on the right to query that. So we see that I'm looking for the fields for timestamp, log level, and message. I want to filter where log level equals ERR for error. I want to sort that then by timestamp in a descending format, and then I want to limit that by 100. It's a very SQL-like syntax for being able to query this information. And what that returns to me here is this visualization. And so I see here this little graph. I see here the logs that match this. And then again, I can dive deeper into this information and understand what happened over this time period. There's a lot of things I could do with this. For example, I could say that I want to find the top 100 most expensive executions for Lambda. And so I'm going to filter here by a type called report. And so Lambda generates lines that start with report, or I should say have the type set to report. I'm going to look for the fields for request ID and build duration. I'm going to sort that by the build duration in a descending format, and then I'm going to limit that to the top 100. And so I see here that I have a whole bunch of functions based on this request ID that have this build duration of, we see here 1300, 1200, and so forth. So this gives me here insight again into the worst performing functions that I have, or at least the ones that ran the longest. So that might highlight a performance issue. It might highlight expensive queries that my application is making. And so what I can do then is expand upon these rows, dive further in, use that request ID to do correlation against the log information that I have, and again, pull out even more data. I could also do things, and again, this is very Lambda specific, where I get a little bit more complicated, but where I want to find the percentage of cold starts of my function over time. And so what you see here is, again, I'm using that type in my line file for report, and I'm going to grab specific data here. So this, again, the syntax on this query is a bit advanced. I'm looking for init duration in a string, and again, that's log data that gets spit out. I'm going to sum it, and then I'm going to divide it by the total count, and then multiply that out so I get a percent. And I'm going to display that as cold start percentage. And then I'm also going to average duration. Unfortunately, that's kind of cut off in this example. And then I'm going to bin this in 5-minute increments. So if you look here, kind of right around underneath in the graph where it says bin 5-minute, you'll see that those are broken out into 5-minute intervals. And then what I see there across those 5-minute intervals is the cold start percentage that happened. And so thankfully, most of them are pretty low, but if we look at that bottom line, all of a sudden there was a huge number of cold starts. And so I'll want to maybe dive into what happened there that caused that. Now, I've got all this information, I have the ability to look at trends, but what I'm probably gonna wanna do is have something to tell me when things have gone wrong. Humans don't do a great job of magically detecting anomalies or issues unless you're sitting there and just refreshing dashboards all day. That's not really effective and doesn't scale well. And so you're gonna wanna have some sort of alert or alarm that can be actioned upon and then allow you to go and investigate deeper into this. So creating alarms in CloudWatch is really straightforward. You can basically find the metric. You can define from the metric what the value is for a threshold, say for alerting and then for recovery, the type of statistic that you care about, the period of time, all sorts of things that you could do in creating alarms for CloudWatch. You just see kind of a couple of example snippets here from what you see inside of the console, and it's pretty much exactly what you would probably expect it to be. So with a Lambda function, perhaps I care about my latency being over a certain threshold for a certain period of time. Maybe I want to look for a certain number of errors over a period of time or any errors. Similarly, I might care about, say, an API gateway, the number of 500s or 400s that I'm experiencing in my application. Are any of those things problematic? So these can be created in the dashboard. They can be created via CloudWatch, via CloudFormation for CloudWatch. So you see here that I have the metric name, which is latency, inside of API Gateway's namespace, and I care about what's called an extended statistic, which is the P99. And so I'm looking for poor performance at the edge of my performance curve, and if that were to breach that threshold, then I'm going to kick off this alarm. Now, what you do with alarms are largely up to you. You can have an alarm go to an email. You can have an alarm go to an SMS, and this is all via Amazon SNS. You can also have alarms trigger Lambda functions as well. And this is another place where people will have this alarm data go off to third-party tools to help them to respond or react to those failures. Now, we don't go too much into today into what you might want to do with that. Again, that's going to depend on your scale, the type of alert, and your situation. But again, it's a fairly flexible thing that you have the ability to control what happens with these alarms. Now, one other capability that we launched last year that's really powerful is the ability for you to do anomaly detection within alarms. Now, again, one thing that you could find that's really common with trying to monitor applications is understanding the threshold and where you want to alert or not alert based on expected performance. So we see here in the top left a chart where there are kind of these periodic spikes. Now, we might expect that we want our performance to be as close to that bottom kind of more flat blue line that continues throughout most of this. And so we kind of have the challenge of, well, do we get concerned about the peak of the spike? Do we care about 50% of that spike? What is normal? What isn't normal? And so forth. And so what the anomaly detection allows you to do is to essentially build confidence bands around the application. So you get to look at it over a period of time and determine, is this something unusual or not? Am I within a certain range of expected performance? And so this is looking at previous data. It's then generating again what it considers to be this band of where there should be a threshold. And then you can create the alarm just to notify you when it has exceeded that threshold, again, based on the historic performance of your application. And so this is an incredibly powerful way for you to reduce the number of alerts that you're seeing based on the fact that it's going to be based off of the previous history of your application and its performance. Now, issues where this can get tricky, places where, for example, your application has a very slow, say, upward tick, perhaps in its latency. And this is where it does make sense for you to have kind of a threshold that you watch for. Perhaps there's kind of a SLO or SLA that you aim for inside of your application. And so having both anomaly detection and some sort of high bar that throws in an alert makes sense to me, at least. Okay, so that's CloudWatch there. Some of the, again, basic and then more advanced capabilities. We'll round up here at the end of the talk talking about ServiceLens. But what I wanted to spend some time on first was tracing. And so again, tracing is the third pillar in the observability tooling. So for tracing at AWS, the core product that we have for this is AWS X-Ray. X-Ray is built into a number of services here at AWS and constantly being built into more. And so in relation to what we're talking about here today, it is already built into AWS Lambda and Amazon API Gateway. Pretty easy to get started. You can either toggle the little checkboxes that you see screenshots of here in the bottom. You can configure this via CloudFormation or AWS SAM. And then in terms of Lambda, we also have an SDK that you can include. Now, the SDK is really powerful, and I would say this is where the real beauty of X-Ray comes in that it gives you really deep diagnostics on what the performance is of the calls inside of your application. Now, you can customize this and wrap any sort of call that you want. It also, by default, will capture calls to AWS services. So as you see here in the two lines in the little green box on the top right, the first one that says var AWS X-ray equals require, and then the SDK. And then the second one, which says var AWS equals AWS X-ray dot capture AWS. Just by adding those two lines, I'm going to see a diagram like you see below here. So one of the next big capabilities of X-ray is that it does generate this service map that you see. Now the service map can provide a ton of insight into things like failure rates and latencies and request rates. But again, by including the SDK, you get some of these extra benefits of seeing what the downstream services are that your Lambda function is talking to. So we see here, for example, again, the service map. We would also get data such as a waterfall trace. So we see here an example of what's happening inside of my Lambda function. And I can determine here that there was a failure. So I see that little red exclamation mark next to the S3 call. And I can dive deeper into this either with log data or potentially other metric data to try to understand what it is that happened and went wrong here. Another capability that we launched last year for X-ray is X-ray Analytics. And so Analytics takes a kind of wide view across a number of your traces and allows you to look at, as we see here, kind of performance over a period of time, distribution of that performance, and be able to pull apart various aspects that might have impacted that. So do I have users that are doing a specific thing on my site where maybe they're doing it with a cart full and then some that don't have a cart? Now, those are examples of things that you could potentially filter on based on the custom attributes that you might have captured from your customers and users that are consuming your application. And so this can become really powerful for you based on the data that you capture. And you can be able to do really customized, again, troubleshooting and profiling of your application based on certain use cases and based on certain needs. And so you can get very granular into the data that you capture. Now, if we take all of this and put it all together, it gives us CloudWatch ServiceLens. So ServiceLens is something new that we just launched right at the end of last year. And you can think of ServiceLens as essentially a single pane of glass, if you will, that ties together CloudWatch metrics, CloudWatch logs, traces from X-ray, the ability to correlate across various bits of your application and the dependencies that are wrapped around them. And so this is going to give you, again, just that one place that you want to go to find out more about what's happening. Now, it's taking this information largely from the stuff that's just built into the platform. So again, metrics and logs are things that we're capturing on your behalf. You don't have to do any custom ones. You don't have to do any, console.log statements. We're going to take all that base information that we gather and correlate it all together for you. X-ray is really the only thing that you would have to turn on in this case that helps complete the picture. And so you do have to enable X-ray in order for ServiceLens to work. And again, it's beneficial to you to include the SDK into your application code so that you can really kind of view the full data that comes with that. So we're going to dive into a demo of this here in a moment, but again, just to kind of give you a visualization, this is for a really simple basic application that is, we're going to be looking here today at the API gateway, talking to Lambda, talking to DynamoDB. And so you see just kind of a straight line service map. What's missing in this screenshot is that there's actually a lot of context here. So when I roll over each of these individual circles, I see things like the average latency that service is seeing, the requests over time, any faults that might be occurring. And as I go from icon to icon here across those services, I'm going to see those various aspects. Now, if there were things like errors, I could dive into those errors. If there were various kind of paths in the application, I could filter by something called X-ray groups that I can create. And so I can get, again, really fine-grained, detailed information as part of this. And then I can dive a little bit deeper into the performance. So you see here kind of a bar chart that represents the performance of my application. And so for the most part, a good chunk of it is fairly performant, but I see all the way at the far end, my P95 and my P99 averages for this application. And those might be areas that I want to dive deeper into understanding why that performance, spreads so far between my P50 and my P95 and P99. And then what I can do is dive really deep into the individual traces. So I can look at an individual trace, I can pull up the logs that align with this request that happened to my Lambda function, and I can again try to debug any of the situations that I might have run into that caused this. So let's take a run here into ServiceLens, into the CloudWatch console, and take a look at what information I can pull out of this application. Now, in this case, the application that I'm using is a demo application that my team uses just to highlight some basic concepts around serverless. And we call this the Caffeinate Me app. And what it does is it takes a map, and we can place this map over a location, and it's going to map to me all of the coffee shops from a certain coffee company, I should say, in that area. And so as I click around here, this is actually using a geolocation SDK with DynamoDB to do lots of queries to DynamoDB. And basically what happens is every time that I click, it's drawing a little geographical bound around this area, and then it's making the call to DynamoDB to find all of the locations that map that. Now that's happening every time I click. It's calling API Gateway. API Gateway is then calling Lambda. And then again, Lambda is pulling that data out of CloudFormation. And so as I just click around New York City here, we can find different areas where there are or aren't coffee shops. Now this is stale data. This has not been updated in any real-time sense or anything like that. It's completely canned. But again, it's just used as an example of a serverless application. Now I've clicked around here a bit, and I've actually had some of my team members clicking here for the last hour or so. So let me go and dive into what this looks like now. So I already have the CloudWatch console open. Let me just go and refresh this real quick. So I see here again that really basic service map of my application, and I'm currently in the service map of ServiceLens. And so what I see here, again, is this application. I have my legend on the side. Now, I don't happen to have any failures or any throttles or any errors, and so it's not going to spit any of that out to me. But I can roll over these various areas. Let's actually look at it from the last hour, we'll say. Here we go. So as I roll over the various services, here is my API gateway. And we see that I have an average latency of 326 milliseconds. I've been doing 1.4 requests per minute. If I go over to the Lambda service, I see the Lambda service is giving me 430 milliseconds. My actual function here at 382 of that. And then if I go over to DynamoDB, I see that I'm doing about 8 requests per minute at 51 milliseconds average latency. So now I can click between these services. And when I click on them, the service map actually gives me a bunch of information. So I can kind of come back in here and I can highlight onto this specific period of time and really kind of drill into what happened here. And so I see built into this my request time P50, again, kind of the average across all of the percentiles of traffic. I also see my P90, so a little further on the performance curve. And so I can pretty easily see that my P90 is, a little higher than I would like it to be and a little higher than my P50, which is expected. We can see the number of requests, and again, there wasn't a ton of traffic here. We got 21 traces there, 5 here, 14 there, and the number of faults. And so it does not appear that there were any faults in this application at this time. When I click onto my Lambda function, similarly, I'll get a whole bunch of information about what happened to it, and I could dive a little deeper into the specific time frame, see the number of requests, see again the latency of this service. And then lastly was DynamoDB. And again, with DynamoDB, I can zoom into this specific time frame and pull out the specific data about performance for this. Now, if I go back to my Lambda function here, I can click on View Dashboard. And the dashboard is going to pull out all of the kind of standard graphs that we would expect this function to have data for. So we see again the latency, the requests, the number of 200s, the number of 500s, 400s, any throttles. And again, none of those show up here. I also don't happen to have any alerts configured for this application, but if I did, they would be showing up here and their state. As I come down here, I see the nodes that exist both above and below this current one that I'm looking at. So I see the service above me, I see my DynamoDB table below me. I come down below here and see just some information about it, the configuration for my function, the runtime, application size, when it was last modified, again, data around the performance of it, and then I can see log information. And so again, this is the log information around specific executions of this function. Now, none of this is reporting any custom formatted data. This is just the basic data that Lambda is going to record for me. And so again, I see things such as the total time that it took for this function to execute, the duration. I see the build duration, which is rounded up to the nearest 100 milliseconds, timestamp, request ID, and so forth. I can also see the X-rate request ID. And so I can dive a little further into this log line here and into this request. And so as I scroll through here, I see the actual segment for this call, or I should say the X-ray kind of waterfall trace. I see that I made a whole bunch of DynamoDB calls. I can see the response back from that. So I had to do a couple of these. And I can see again the total performance, the time that it took. And I know that this took me 277 milliseconds. And again, all of these were successful queries. And so everything here is green. So this is all good data for me, and everything there is the way I'd expect it to be. Now I can come back here to my service map again and click on my API gateway, and I can click on view traces for that. And now if I actually click on this here, what I get is the ability to dive deeper into certain aspects about this application. As you see here on the left, I have a number of filters that I could follow through on. Things such as response code, user agent, and this is all information that exists in the logs today. I could take this and I can filter. So I see here a number of client IPs. I see here user agents, and again, this is from myself and my team clicking on this. And so I could say that I care just about my Windows customers, for example, here. So I can add this to a filter. And I can see the number of traces. So I can tell that it looks like there were 10 traces in the time period that I'm looking at here, which is the last 6 hours. I can come down and see what the performance was of each of these. So about 50% of them were really quick. My 50th percentile here, I can go and I can filter upon if I wanted to. I see my P95, my P99. So let's see here. Let's go ahead and add that time to my filter. So now what I see is the response time within a certain range of time. I see again the user agent, and I can continue to look at this information, and I can view the one trace that was relative to that. So let me actually get rid of this. Let me actually filter by my worst performing function. So I can, again, I see the dividing line here between P95 and P99. Let me see what data points I get for P99. So this is going to give me my worst performing functions, or my worst performing API calls, I should say. And so I see here that there are 3 of those API calls. And so I can click down on them by trace. I see now the full trace for these calls. And then I can dive into what happened here. So I see that this, again, was an API gateway call. I see the call to API gateway. I see then the call to the Lambda service. I see then my Lambda function being called. And I see all of the calls that Lambda made again here. And it seems like this one just took just a little bit longer than the previous one did. Again, I see a number of bits of information about the configuration of this, things like extra sampling rates, segment IDs, and so forth. And then any logs that might have existed for this trace. In this case, there weren't any logs that were captured for this. So again, I can get really deep information into this, diving into why this might have performed the way that it did, again, based on the search that I did here. I could, in general, just look for all of the slower requests, for example, here. So I could take a look at all of the requests that came that were at the higher end of my performance curve. And so again, this gives me a really easy way to dive into everything that's happening with my application. Now again, unfortunately, I don't happen to have any errors here. If there were some errors or faults, then I could dive a little deeper into those. But again, as you can imagine, you would see them represented visually. You can dive into the service itself and understand aspects about the metrics for the service. You can then dive into traces and logs, and then ideally start to get deep insights into how your application is performing and why it performed a certain way. And again, this is a service map, including data from CloudWatch metrics, CloudWatch logs, and X-ray. So as we saw there, I was able to kind of bring together a number of things, but some of you are probably wondering, what are the kind of official steps that you would want to go through when troubleshooting a serverless application using these tools? And so the troubleshooting workflow in my mind is you would receive some sort of notification. So again, hopefully you're using something like the anomaly detection inside of CloudWatch to understand that you do have an alarm or alert that you need to respond to. You get that alert. My next step would be to open up ServiceLens, take a look at my service map, see if I can visually identify any points of interest. Again, any red on those circles, anything that looks like a fault, a 500, something that I might want to dive into. I can then dive into the specific traces and understand, at least in the situation of a serverless application in Lambda, what call failed. Can I deduce that that's failing more often than once? Why did it fail? Was it latency? Was it an error code? I could then use X-ray analytics, which is again a component of X-ray, to look specifically at that individual service and understand, has its performance gotten worse? Has this happened over time, or did this just happen immediately? Can I correlate any other sort of errors that might have happened? And then finally, I can use log insights to search for similar situations with the log information that I see, and then be able to ideally, again, use this information to give me some sort of driving point towards what it is that might be going wrong with my application. So in closing here, we've gone through a whole number of concepts here today around observability. And again, I like to refer to this kind of nice little triangle that we see here on the side, including the 3 pillars of observability, which is logs, metrics, and traces. Now, again, it's more than just monitoring, right? You really need to understand how your application is performing, how it normally performs, what you consider to be kind of good or bad. Again, there's a lot of kind of gray space between my services up and my services down. Now, we talk about, again, the culture and process side of this. This is where it really pays to be an organization that is focused on understanding, do you have all the right data to be able to make decisions? Do you have enough data over a period of time? Are you making sure that you're capturing all the various business metrics that you could to understand what your customers are doing? And then again, lastly, with CloudWatch and X-Ray, there's a number of benefits built into these just out of the box. And then there are some things that you can do yourself. So an embedded metrics format, again, provides kind of a powerful 2-for-1 for you, where you have the ability to generate a structured log line and also get metrics, also be able to pull in data via insights, also be able to then pivot further on that information inside of ServiceLens. And then lastly, ServiceLens gives you that single pane view across all of this to be able to dive just really deep into what's happening with your application. Again, pull out those kind of outliers and be able to give yourself as much information to start figuring out further what you might need to do. Do I need to tweak the memory of my Lambda function? Do I need to increase, say, the read or write units for a DynamoDB table? Am I experiencing, abuse by a customer that I need to apply a usage tier and API gateway? And so all of those things are going to require all of this tooling to be in place for you to be able to come with those conclusions. So with that, I want to thank you again here for joining me here today. You can read about this as well as a ton of other things on AWS at amazon.com/serverless. This is kind of our homepage for all things serverless, links to developer tools, links to our partners. Again, we've got a ton of partners in the observability space that can help you with logging or metrics or monitoring, anomaly detection, alarming, or any of those things. So you can find links to those there. Under the resources tab, you will see links to other tech talks such as this, as well as things like customer testimonials, white papers, blog posts, and so forth. And so check that out if you want to get a little deeper into serverless content. Again, I want to thank you for being here today and asking questions during this. There's been a flurry of questions, and I know my team has been cranking away trying to answer those. We'll stick around and try to answer a couple more questions here today. But again, want to thank you for coming. Hope that we see you again in a future Tech Talk. Please do answer the poll questions here and give us as much feedback as you can. We use this to help guide this Tech Talk program and try to provide the best quality content for you that we can. Again, my name is Chris Munns. I am Senior Manager and Principal Developer Advocate for Serverless at AWS. You can reach me at munns@amazon.com or at Chris Munns on Twitter. Always happy to try and help you out. Again, thanks for joining me here today.